In this lecture, we will be seeing another example of construction of Mealy machine. So here is our task. Construct a Mealy machine that gives 2's complement of any binary input. Assume that the last carry bit is neglected. So our task is to design a Mealy machine that takes any binary number as the input, and it should give the 2's complement of that binary number as the output. And we assume that the last carry bit is neglected. So before we start, let us try to understand what is a 2's complement. So we have already discussed 1's complement in one of the previous lectures, and let's see what is a 2's complement. 2's complement, in order to get 2's complement, it's very simple. 2's complement is nothing but the 1's complement. It is the 1's complement of any number plus 1. This will give you the 2's complement of any number. So let's see some examples. So for example, we have this binary number 10100. And what will be the 1's complement of this? 1's complement is very simple. Just flip the bits. 1 becomes 0, 0 becomes 1. So here it is 0, 1, 0, 1, 1. And for getting the 2's complement, what do you have to do? You have to just add 1 to this. Now, what do you get if you add 1 to this? 1 plus 1 is 0, carry 1, and carry 1 plus this one again gives 0, and we still have 1 in carry. Carry 1 plus 0 gives 1, and this 1, 0. So this is the 2's complement. 0, 1, 1, 0, 0. Okay, let me take another example. Let's take another example over here. Let's say 1, 1, 1, 0, 0. So what is the 1's complement of this? 0, 0, 0, 1, 1. And you add 1 to this to get the 2's complement. So to get the 2's complement, we add 1, and what do we get? 1 plus 1 is 0, and 1 carry, and carry 1 plus this 1 gives 0, and again 1 carry, and carry 1 plus this 0 gives 1, and this 0, and this 0. So this is the 2's complement of this number. Let me take one more example. 1, 1, 1, 1. What is the 1's complement? 0, 0, 0, 0. And 2's complement will be plus 1. And what do you get? 1 plus 0 is 1, and then 0, 0, 0. So this is the 2's complement. Now, why I took this many examples is that when you look at this 2's complement, you can see a certain pattern that it follows. Let's see what is that pattern. If you look at this, when you see that, let us see this example, and in this example, when you look carefully, you find that this is the example, this is the question, and this is the 2's complement of this question. So this number, whenever you see a 0 here in the beginning, this 0 is left as a 0. And when you see another 0, that 0 is also left as a 0. And when you see this 1 is also left as 1. And after you see this first 1, then whatever bits you see, they are complemented. This 0 here, it becomes a 1. And this 1 here, it becomes a 0. Alright, so we'll always start reading from the LSB to the MSB. This is the LSB. LSB, or the least significant bit, and this is the most significant bit. And we will always start reading this way. Okay, now let me take a look at this example. This is the example. So whenever you see the first 0, that is left at 0, the second 0, that is also left as 0, and then when you see the first 1, that is also left as 1, and after this first 1 that you see, whatever bits you see after this, they are complemented. 1 becomes a 0, this one also becomes a 0. So you see that whenever you see zeros in the beginning, they are left as zeros, and the first one that you see is also left as 1, and whatever bits you see after this first one are complemented. Okay, now let us see this example where there are no zeros at all. It is just 1, 1, 1, 1. So what happens here? This 1 is left as a 1, and then the rest of them are complemented. So the first one that you see is left as 1, and then the rest of the bits are complemented. So from this we can get an idea of how to design our Mealy machine so as to give the 2's complement of any number as the output. So how can we do this? Let's see this. Let me start with a starting state which I will call state A. Okay, A is my starting state, and A on getting input 0, let it give the output 0. Why? Because whenever we see these zeros in the beginning, we are leaving them as zeros itself. So we assume that we are always starting from the LSB to MSB. We are going this way. We will read it this way. So when you see the first zeros, we leave it as zeros. Okay, and then A on getting the input 1, I will send it to another state called state B. Okay, and A goes to state B on getting input 1, and what output should it give? It should give the output as 1 itself. Why? We saw that when we see the first one, it is left as 1 itself. So when you see the first one, you give output as 1 itself and it goes to the next state. Now we have reached the state B. Now what happens in state B? Here we have completed what happens on these zeros and the first one. Now in state B, whatever we get after this one should be complemented. So B on getting input 0 should give the output 1. That means it is complementing it. And in the same way, B on getting input 1 should give the output 0. That means it is complementing it. Okay, so now we have completed the Mealy machine, which gives the 2's complement. So here we see whenever we get the first zeros counting from the LSB, we leave it as zeros, and the first one also we leave it as 1, and then after that whatever you get, it is complemented. So let us take a few examples and see if this is working. Let us check this example itself. Okay, 1 0 1 0 0 1 0 1 0 0. So as I told you, we have to always read it from the LSB to the MSB. That is how we are designing our Mealy machine. So let me start from this 0. So this 0, it starts from the starting state A, and A on getting input 0, what happens? It stays in A itself and gives output as 0. Okay, now let me go this way. The next one is 0 again, and I'm still in state in state A. In state A on getting input 0, what happens? It stays in state A itself, giving the output 0. Okay, and now I finish this 0 and I come to this 1, and coming to this 1, A on getting input 1, it goes to state B. Okay, it goes to state B, and on getting input 1, A produces the output 1. Okay, I get this output 1. Now I come to the next one, that is 0. I am in state B. B on getting 0, what happens? It stays in B itself, and on 0 it produces the output 1. Okay, it produces the output 1. And then I come to the next one, which is this one, and I'm still in state B. B on getting input 1, what happens? It stays in B itself, giving output 0. Stays in B itself, giving output 0. Now this gives us the 2's complement of this number. Let's see if it is correct. Here we calculated the 2's complement as 0 1 1 0 0 0 1 1 0 0. So we are getting the 2's complement of the binary input that we provided. So we have successfully designed the Mealy machine that takes any binary input and gives the 2's complement of that binary input as the output. You can take these other examples and check. You will see that it is working fine. So I hope this example was clear to you. Thank you for watching and see you in the next one.